This is the first out of 4 videos that I have created to show you step by step how to derive the maximum likelihood solution and standard errors for a linear regression model with Gaussian errors. In that video, I provide you with some takeaways and an introduction to the problem, basically writing down the linear regression model with Gaussian errors. The second video of the sequence derives the log likelihood function. In the third video, I show you how to find the maximum likelihood estimates. And finally, the fourth video of that sequence shows you how to get the maximum likelihood standard errors. Now let's start with some takeaways. That sequence of videos teaches you that the maximum likelihood parameter estimates of a linear Gaussian regression model coincide with the respective OLS parameter estimates. Yet you also learn that the small sample maximum likelihood estimate for the variance of the regression error is biased downwards, but becomes unbiased as the sample is growing. This says that the maximum likelihood estimate for the variance is consistent. I also show you explicitly that the maximum likelihood standard errors coincide with the OLS standard errors. While OLS doesn't provide the standard error for the estimate of the variance of the regression error, the maximum likelihood approach will provide you with such an estimate. So let's consider the linear regression problem that we study with Gaussian regression errors. It's written as follows: y equals x beta plus epsilon. So y and x are observed, beta and epsilon are not. Y has dimension t times 1, x has dimension t times k, and beta is of dimension k times 1. So you can see that y could, for example, be a time series of returns of macro growth with t observations. X would be your explanatory variables. You have k of these. One dimension could be the constant, and then you have time varying covariates. And epsilon here is the Gaussian process. Its variance is a constant, sigma square, and it's multiplied by I, which here stands for the identity matrix, which would have dimension t times t. Now, in the next video of that sequence, I will derive explicitly the log likelihood function for that Gaussian regression model.
Got feedback? We would love to hear it. Please drop us a line. And if you liked the video, give it a thumbs up. And don't forget to subscribe to the channel.